Every year, M4 through Nile Well organizes a co-production program. The first cohort started in 2023 with journalists and scientists from Nile Basin countries including Rwanda. Journalists and scientists from Rwanda who attended Cohort 1 worked on special temporary assessments on groundwater resources for monitoring and make early prediction of drought in eastern region of Rwanda. In Rwanda's eastern province, some people are still struggling to find enough water as the sun shines hot frequently. Some rivers and wells are drying up, and some families must walk long distances to fetch water. Some wake up very early in the morning and travel for hours carrying heavy jerrycans just to get few liters of water for drinking, cooking, and washing. Farmers are also worried because of their crops are drying and their animals have no water to drink. Without enough water, life becomes very hard. Marie Claire Uwamariya is a Nile farmer in Gahulile Cell, Umuyanje village, a remote area in Ngoma district of eastern province of Rwanda. She wakes up at 4 a.m. dial and embarks on the agricultural works conducts on a 1-hectare piece of land. However, every morning, Uwamariya must spend at least 2 hours trekking and fetching water pumped from the Rwabyumba swamps, Lebelo village in Ikazo sector. It's a tedious ordeal she wishes could change. We need water for various household activities, but we don't have enough, she says, adding, "We have to travel kilometers and kilometers to access water." Rwanda's eastern province, where drought prevails, covers 3 central water bodies and catchments. Those water bodies we have Muvumba, Akagera Upper, and Akagera Lower. As Rwanda faces irregular rainfall, the government uses groundwater monitoring techniques for better ways to predict water shortage in the region. One solution under consideration is groundwater. Another solution to water scarcity in eastern Rwanda. Dr. Judith Uwihirwe, a lecturer at the University of Rwanda, College of Agriculture, Animal Sciences and Veterinary Medicine, and a researcher in hydrogeology and related hazards, explains how this project works.
The project is devoted to using the global gravity-based groundwater, which is called in abbreviation G3P, which provide data at the global scale, including Rwanda, of course, and the Eastern Province, of course. So we aimed at using that product, that G3P product, to be able to predict the status of groundwater in the eastern part of Rwanda, so that we can know the current status, if it's depleting, if it's restoring, to be able to take measures within time. For today, we are here to validate such data. We are here to validate the G3P data because the data are being taken at a global scale. Of course, they are taken using satellite information. So we need to confirm, we need to validate such data using in situ data. Today, we are in a catchment called Muvumba at a borehole called Ngarama. This borehole is locally named Ngarama. So we are here to record the data of this Ngarama borehole to be able to validate the global data that we get from the G3P product. This project, of course, apart from being funded by the Nile Basin Capacity Building Foundation, we do also collaborate with Rwanda Water Resources Board that that is mandated to monitor and also manage all boreholes in the whole country.
Dr. Judith also gives more details on where this project is being conducted and how they realize that groundwater level is increasing or decreasing.
Yeah, as I told you, as I'm the principal investigator for this project, and this project is being conducted in a free catchment located in eastern province of Rwanda. Those catchments are include Muvumba catchment that we are in now, also Akagera Upper catchment, as well as Akagera Lower catchment. We are here, of course, to validate the G3P data that I told you before, and to validate such data, we use in situ measured groundwater data. To take such measurements, there are many ways, but the cheapest one, include using this tool that we call the dipometer. When you insert this tool in the pipe or the borehole, as well as the piezometers, you can easily record how deep is your groundwater. So in such way, you can know if your groundwater is decreasing or increasing, and you can easily know if you are moving towards drought or restoration of groundwater. Another way to take groundwater measurement is an automatic one, where we use a diver data logger, which is installed in the borehole, and it's able to take measurement of groundwater levels or the column above the sensor or above the diver, and then give the situation of groundwater in a given borehole, piezometer, or any other pipe.
Water scarcity in Eastern Province is a serious problem. Florentine from Luha sector in Bugesera district requests for advocacy to the access of water. She says, what we wish is to make for us an advocacy so that we can get water, because lacking water is a great problem to a citizen of Luhuha. Access to water would speed up development for a resident of Luhuha. Mr. Innocent Nzeimana, a Deputy Director of Research and Innovation at Agrisa Kunguka, a researcher who is in charge of entering meteorological data and groundwater data, explains how groundwater is related to meteorological data and why they consider rainfall and temperature while measuring groundwater level.
Here I'm a researcher, and I'm in charge of entering the meteorological data and the groundwater monitoring data. Here, according to the data from meteorological board, it is a Rwandan meteorological region where we get the data about rainfall and temperature. Here we interlink with this groundwater, because rainfall it contributes in recharge of water, groundwater, that will increase the level of water in underground. And here we consider also the temperature. We take maximum temperature and minimum temperature, because this temperature contributes to evaporation, where this evaporation reduces the level of water in underground. So after this, we have to interlink them to see the level of rainfall that will charge the groundwater, and to see the process of evaporation that will contribute to the reduction of that groundwater. So after making a difference, according to the difference, we will get the decision, or we make a decision what is going on. It is a drought or other situation that we can also take measures to handle it.
How the groundwater level is measured through borehole. Mr. Focus Ukwigize, the groundwater monitoring officer from Rwanda Water Board, explains how they measure the variation of water level from the ground.
And this is a borehole. It monitors the groundwater variation. And here there are two methods that I'm going to use to measure the groundwater variation. The first instrument that I'm going to use is called deep meter, and it measures the water level from the surface, from the ground surface. Once this deep meters, it has a sensor. Once this sensor touches water, it beeps, and then I record the water level from the ground surface. For example, here it is telling me that water is at 2 meters and 25 centimeters from the surface of the water to this cap. Another instrument that we use to monitor the groundwater, it is this instrument. This instrument is data logger. This data logger, it has a sensor that goes into the water, and it records the daily change of groundwater, that groundwater variation in summer, in rainy period, and you can, for a given period, they take it and they download the data by using this computer. For example, after three months, you may come and download your data to see what have been done in groundwater. And here you can even measure the groundwater by using this device called the magnetic rod, where we tap it on this data logger, so that we can record the current change of groundwater.
Some people from Eastern Province are still struggling to get enough and pure water. On the other side, Rwanda is striving to get enough and pure water for everyone. Groundwater is a vital source of drinking water, especially in areas with limited surface water. It plays a key role in agriculture, supporting crop irrigations during dry periods. Also, protecting groundwater ensures its availability for future generations and helps prevent contamination that can harm both human health and ecosystem. Dr. Uwihirwe Judith, a lecturer at University of Rwanda, proposes possible solutions, including finding alternative sources of water, putting limitation on groundwater use for irrigation, also putting regulations and limitations on groundwater pumping, and adapting groundwater preservation, restoration and replenishment techniques to ensure the balance between groundwater recharge and discharge in eastern region of Rwanda. Rwanda set ambitious goals to improve water access to its citizens. The government aimed to achieve universal access to basic water supply by 2024 and safely managed water services by 2030. The Nile Basin Initiative works to protect water resources in the Nile River Basin through cooperation and sustainable management. The Nile Basin Initiative promotes joint efforts among Nile Basin countries to address water scarcity, improve water quality, and reduce the risk of conflict over water. Key actions include implementing projects that focus on water conservation, improving irrigation efficiency, promoting wastewater treatment, and fostering regional cooperation for equitable water distribution and sustainable development. Nile Basin includes 11 countries that share the Nile River's water resources. These countries are Rwanda, Ethiopia, Egypt, Sudan, Uganda, Kenya, Tanzania, Burundi, Democratic Republic of Congo, South Sudan, and Eritrea. Researchers say that Nile Basin countries must protect groundwater to ensure a sustainable water supply for drinking, agriculture, and ecosystem preservation in the face of growing demand and climate change.